All right, hello everyone. Welcome back to our third lecture of the semester. And this is we are on section 2.6 today. And these are our objectives for this lesson. A, find the equation of a linear function given its slope and y-intercept. So look at this. Find the equation of a linear function given its slope and y-intercept. B, find the slope and the y-intercept from the equation of a linear function. C, find the equation of a linear function given the slope and a point on the line. Again, find the equation of a linear function given the slope and a point on the line. And D, find the equation of a linear function given 2 points on the line. So I'm looking for equations, a linear function, which makes up the equation, given these parameters. All right, and there's 4 of them, and this one's very easy. I can tell you ahead of time. Find the slope and y-intercept from the equation of a linear function. That will be easy. Okay, and then I'll show you about C and D, how to do those. All right, but first let's talk about a linear function, shall we? All right. All right, prefacing our examples, here is an example of a linear function and the form that it takes, written in what's called slope-intercept form. Slope-intercept form. All right, whereas m equals the slope, and b is going to equal the y-intercept. Always. Okay. Now, if I get an equation that's in standard form, a standard form of equation is like ax plus by that equals c. If I have an equation in standard form, then I could change it from standard form into the slope-intercept form and get all the information I need. So the slope-intercept form of the equation is like the God. You can do everything from that. And I want you to do your best to understand what's going on here in this chapter. It'll make things easier down the road. Okay, so if I have an equation in slope-intercept form, that means I'm going to have the coefficient of x, which would be m. That's always going to be the slope. And it's just the number. You don't include the x with that. B is what's called the y-intercept, meaning if I have a graph here, and we know this is x and this is y, if I have an equation where y equals mx plus b, and I say x equals 0, when x equals 0, that means x is going to be here. Let's see, anywhere on that y-axis, going up or down. However, sometimes we have a positive number here, and sometimes we have a negative number. But whenever x is 0, then go along that line. Remember, we're at x is 0, so that's here. And there is, if I go to the right, then I got 1, 2, 3. To go to the left, I got -1, -2, -3. So the 0 is right on the axis, the y-axis. Okay, so if x is 0, that wipes this away, and I've got y equals b, and y would equal a number. So that point for the y-intercept is going to be up and down or along the y-axis somewhere, depending on what this number is here. Okay, let's go on. Okay, we've got a problem. All right, we've got our first example in the practice problems. it says find the equation of the line with slope 2/3 and y-intercept 1. Write your answer as a linear function, then graph the line. All right, so let's see. These we're starting off with the easy ones, and I always kind of have a tendency to take this with me. I just jot it down for reference. Makes it a little bit easier for me. All right, and it's saying find the equation of the line with slope 2/3 and y-intercept 1 and write your answer as a linear function. Well, this is a linear function. You can tell it's a linear function because both our variables, y and x, are raised to the first power. So that tells you it's going to be a straight line graph. All right, so put that in your memory bank. That's important to remember that thing. All right, so if I'm writing the equation of a line with a slope of 2/3, where's the 2/3 going to go? It's going to go where the m is. So far I've got y equals 2/3 x and then plus b. The y-intercept is 1, so that means it's going to be plus 1. All right, and now I'm done other than graphing it. I replaced the 2/3 with the m, or the m with the 2/3. I replaced that, and 1 is the y-intercept. So this is the equation of the line, and I'm done. Okay, they'll ask you sometimes to write your answer in standard form. Okay, so if I were to write, I'll wait till I come to a problem before I do this one. We'll tell you how they want the answer to be, and then we'll do it at that point in time. Okay, so that's all there is to that one. If I graph this, I'm going to draw like a generic graph, I think, for this one, or, well, we're kind of new here, or young in the semester. Let me grab a graph. Okay, so if I'm going to graph this equation, it's in slope-intercept form. So what do? We always start at 1. Here's 1 when x is 0, y is 1. And then from this point on the y-intercept, I'm going to figure out what my slope is, which is 2/3. So that means I'm going to do the rise over the run. I'm going to go up 2 and over 3. 1, 2, 3. And this is the equation of that line that will be graphed. Let's see, how can I do this? There we go. I think that maybe will suffice, but you get the idea. Okay, and then that's the graph of this function. And we're done with our first example. All right, in practice problem 2, we've got give the slope and the y-intercept for the line 4x minus 5y equals 7. Well, I need to bring this out or remind myself of this. And quite nicely, I'm going to rearrange this 4x minus 5y equals 7, which we call in standard form, and I'm going to rearrange this so it's in slope-intercept form. And once I have it in slope-intercept form, then I'm going to quite easily be able to tell what the slope is and what the y-intercept is. Okay, and that's all there is to it. So I've got 4x minus 5y equals 7. And I'm going to subtract 4x first. I'm going to write this as negative 5y equals negative 4x plus 7. And divide everything by negative 5. Okay, and watch carefully. I have little alterations to make, which is negative divided by a negative is a positive, so this is going to end up being just positive y. And then that's going to equal 4/5 positive x minus 7 over 5. All right, I got a positive divided by a negative, which is a negative, and it remains a negative number. Negative divided by negative is positive, so this 4/5 turns to 4/5. Or negative 4 divided by negative 5 is the same as positive 4 over 5. Nevertheless, this is my equation in slope-intercept form. Now I can answer the question. And the question is, give the slope and the y-intercept for the line 4x minus 5y equals 7. So I could say m equals 4 over 5 and b equals negative 7 over 5. Done. All right, practice problem 3. They just want us to graph these equations using the slope and the y-intercept. Just another way of graphing equations, which is the most efficient, I may add. All right, so if it's telling me to graph the linear function negative 2x over 3 plus 2 using the slope and y-intercept. Okay, so what do I know? So let me say something about this and how that's written. First of all right, many times we see it as y equals 2 over 3 with the x in the middle, plus 2. Okay, and that's negative 2 over 3. Okay, I wrote it carefully this way to mean the same thing, because this x is really over 1. So that means when I multiply two fractions, it's negative 2 times x, which I'm doing here, right there, negative 2 times x divided by 3 times 1, which is 3. Okay, I did not want to write this up as 2 over 3x this way. Or I should say when I write it on a slant, the slanted way of writing a fraction. 2, 3x, which you can do in your calculator, but not here. This is really showing an incorrect form. The x looks like it's going with the 3, and actually it is, but we want it to be with the numerator. So that's why I have it written there as such. Nevertheless, I can see that if I'm graphing this, my y-intercept is going to be positive 2. So that's going to be marked right here. And then my slope is negative 2 over 3, not the x, just the negative 2 over 3. So from the y-intercept here of 2, I'm going to go down 2 and over 3. And that's a negative slope as indicated as such. So I'll hand draw it for now for the sake of time. And there's my graph of that equation. Okay? Once it's in slope-intercept form, it's pretty easy to graph because you know what your y-intercept is, and then from the y-intercept, you count whatever the slope happens to be. Okay, another useful formula that we're going to learn today is the idea of having what's called the point-slope form of the equation of the line. All right, and just as the name implies, point-slope, well, what that's telling us is they're going to give us a point, x, y, along with the slope, which is m, and given those two parameters, then I can find the equation of the line. Give me one point in the slope, then I can find the equation of the line. And I will use this equation to structure my problem so I can solve for y and end up with this equation in slope-intercept form. Okay, so let's go to an example. So without turning this off and all that, I'm going to go to the example practice problem 4 first. Okay, and let me jot that down. All right, practice problem 4. Find the equation of the line with slope -2 that contains the point -4, 3. Write the answer in slope-intercept notation. Okay, let's see here. So what I need to remember and to have is y minus y1 equals m times x minus x1. All right, so here's my equation in point slope form. Notice the x1 and the y1, these subscripts. That just means where I'm going to identify where the x and the y go. I only have 1 point, so this exemplifies that it's 1x, and this is 1y. All right, m we know is a slope, so I'm just going to plug in what I know. So what do I know? I know that y minus y1, and y1 is 3, so it's y minus 3 equals m, which we know to be -2, times x minus x1. Now x is -4, so I'm going to write it as x minus -4. And we know that when we have two negatives like that, that it changes to be x plus 4. Okay, so let me just get a dab here and get rid of that, and I'm good. All right, so that's what happens when you're subtracting a negative number. It turns positive. So this is my equation thus far in point slope form, but I've got to write this in slope intercept form. All right, so how do I do that? Well, I could distribute first. So I could say what's y minus 3 equals -2x minus 8. And then I can add 3 to both sides to get the y by itself. And I end up getting, I'll put it down here. It's going to be y equals -2x minus 5. -8 plus 3 is -5. So this is my solution for that part. And that was example 4. And did we write the answer in slope intercept form? Okay, we're done. That's it. And again, what did I do? I used the example, not the practice problem. So there. I want to do the practice problem so I can leave the example for you to read over in case you're having a hard time solving problems similar to that. Okay, so this is an example 4. And again, I'll be doing this probably the whole semester. I can't keep it straight in my head that I'm doing the practice problems and not the example. All right. Nevertheless, that's how it's done. Let's move on to our next example of finding the linear function using 2 points, which is probably the hardest. All right, so I'm just going to stay with us here. Scroll up some, and this is practice problem 5. All right, so I'm going to change color here. Practice problem 5. Do that. Okay, we've got it. Practice. All right, here it is. Practice problem 5. Find the equation of the linear function through those 2 points, 2, 5, and 6, -3. Write your answer in slope-intercept form using function notation. Okay, in this problem, this is the hardest type of problem because you're given 2 points, but you're not given the slope. All right, so what do we do with that? Well, if I have 2 points, then I can find the slope using the fact that m equals y2 minus y1 over x2 minus x1, which you remember to be is the slope equation, the equation for slope and how we can find it. So let's find the slope. So here I've got y2 minus y1, so that's going to be negative 3 minus 5 divided by 6 minus 2. Okay, here's my negative 3, y2 minus y1, and then x2, which is a 6, minus y1, x1, which is 2. All right, so when I calculate this out, I got negative 8 divided by 4, and that's going to give me negative 2. So m equals negative 2. Okay, as I go about doing that, remember we needed the point slope form. I have 2 points, but you can choose either one. You choose here which one you want to use. Now me, I'm going to use the 2, 5 because they're both positive, and I don't have to deal with the negatives. Not that it's a huge deal, but it just, every little bit helps. All right, so I'm going to use my y minus y1 equals the slope m times x minus x1. And I'm going to plug that in using slope of m equals negative 2, and I'm going to use the point 2, 5. And I'm going to use this information and fill in my point slope form equation. So what am I going to have? Y minus 5 equals m, which we said is negative 2, times x minus 2. And I will get my equation as needed. All right, so let's distribute. I got negative 2x plus 4. Okay, and then I'm going to add 5 to both sides. And if I add, I'll do it here as well. Add 5 to both sides. Now, I'll bring down my y. This is 0, so I don't have to write anything. And I've got, what? Negative 2x plus 9. And this is the equation of the line that I'm looking for. And we're done. Pretty slick and pretty easy. I hope you find it to be easy as well. All right, going on, let's see what else we got here. Standard form of the equation of the line. All right, that's, let's see. I'll do that one as well. All right, let's do that one. I was going to say, I'll give you some extra practice here, kind of get a look at, if I want to change this to be in standard form, then standard form, remember, was ax plus by that equaled c. So I can see that the ax and the by are on the same side of the equation. And what I like to do is to have my beginning term, the a, be a positive number whenever possible. So in this case here, if this is my equation in slope-intercept form, I want to change it to be in standard form. Well, I'm going to add 2x to both sides. Add 2x. And when I do, I end up with 2x plus y that equals 9. And the whole general idea is that you're going to have integers as your coefficients. You will not have fractions. If I had a fractional component in this problem, I would eliminate the fraction. And when we get to a problem like that, I'll show you as well. Okay, but this is in standard form, so that kind of lends credence to this equation if they were to ask it for that in standard form. All right, let's go on and see what they have for us to do in practice problem 6. All right, here it is. Pretty tough problem, I may add. It says, find the equation of the line through 3, 2 that is perpendicular to the graph of 3x minus y equals 2. Write your answer in standard form. All right, we have 2 issues here that's going on. First of all, what does perpendicular mean? All right, perpendicular is a line So here's a vertical line. A line that's vertical, then a line that's perpendicular to it will cross it and form a 90-degree angle. So that's the whole idea of perpendicular. These two lines are perpendicular to each other. They cross, they form a 90-degree angle. Okay, if you remember from beginning algebra, when they were perpendicular, what is it that we had to do? For perpendicular and parallel. The other term was parallel. So if the lines are parallel, that meant the slope was the same. That's the easy one. And the other, if I have a perpendicular line, then I've got to figure out what will make the perpendicular line form. What do I have to do? So let's write this out first. The first thing I want to do is take this graph, this equation that's in standard form, and I want to write it in slope-intercept form. So I've got 3x minus y equals 2. Okay, I'm going to subtract 3x, both sides of course, and I've got negative y equals negative 3x plus 2. And then I'll divide everything by negative 1. And then this equation becomes positive y that equals 3x minus 2. And this is my equation now that's in slope-intercept form. All right. So now I want to find the equation of the line through 3, 2 that is perpendicular to this graph of 3x minus y equals 2. All right, so we have to find the slope. I've got the point here. I got to figure out what the slope is. Well, if the slope is 3 in this equation that we rearranged, then the slope perpendicular to 3 would equal 1 over 3, but one of them has to be negative. Since this is positive 3 to start, from here to here, these are the same 3's, then this has to be negative. So the slope I'm looking for is negative 1/3 to solve this problem that I'm working on. This will create a line that's perpendicular to this line. I want to get it so it equals, when I multiply the two, it equals negative 1. So again, 3 times negative 1/3 equals negative 3 over 3, which equals negative 1. So it works. If I have, I'm on a roll a little bit, so if I have a, I'm going to practice with you now. If I have a slope that is 2 over 3. What would be the line that would be perpendicular? What would be the slope of the line that would make it perpendicular to this slope? All right, so I know that 3 over 2, when I multiply these two, will equal 1, but one of these has to be negative. So since this one is positive, this has to be negative. And there's the line or the slope that I would use in this type of problem. If I have a slope of negative 4, what would be the line perpendicular to negative 4? It would be 1 over 4. I've got a negative times a positive, which will give me the negative. 4 times 1 over 4 is 4 over 4, which equals 1. And I'd end up with negative 1. Okay, but anyway, we'll attack that a little bit more as we go, when we get into some heavier problems. All right, so did I finish this one? Write your answer in standard form. No, we're not done yet. All right, so I have decided that the equation now, I have the slope here that's perpendicular, and it's minus 2. So my equation becomes y equals negative 1 over 3x minus 2. So there's the equation that we're looking for. I changed the slope from 3 to negative 1 over 3. because in the problem it says, find the equation of the line through 3, 2 that is perpendicular to this line, to the graph of 3x minus y equals 2, which is a line. Okay, so that would be my final answer here. The original slope was 3, but they wanted the line perpendicular to the slope of 3, and that's negative 1 over 3. I just substituted it out. The y-intercept stays the same. Okay, so now one last step is I got to change this, it's in slope-intercept form, to standard form. And now what I do is I'm going to clear the problem of the fraction. I don't want fractions. I can't bring this over and say positive 1/3 x plus y equals negative 2. No, they got to be integers, the coefficients. So what I do is I multiply everything by the denominator, which is 3. 3, well, let me get some color to this. This is important. 3, 3, and 3. I'm multiplying each of the terms by 3. And then that's going to give me 3y equals negative x, negative 1x if you will, minus 6. Now I can put it in standard form by adding x to both sides. Just merely bringing that x from the right side to the left. And I'm going to end up with x plus 3y, that equals negative 6. And here's my answer in standard form. Y equals 2, 3x minus y. Okay, I think I did that right. And I multiplied everything by 3. Yeah, I'm pretty sure I did that right. Okay, that's it. Thank you. And that's it for 2.6. Yes, it is. All right, have a great day.